Mga friends, welcome to Winnie Luna Nahiyalidog channel on mathematics and other related topics. For this video, our discussion is about continuously compounding interest. Another lesson of the subject mathematics of investment. Okay, so what is this all about? When lending institutions compounded the borrowed amount for more than 1 year, or for more than one every year, it means that they would have an interest day according to the number of conversion periods agreed upon. This further implies that every year your balance would increase by a factor of 1 plus j over m raised to m, where j is the nominal rate and m the number of conversion periods or interest days in a year. The frequency of interest days in a year may actually be done daily, hourly, or even continuously, meaning that your balance grows by a small amount every instant. Due to this, the accumulation factor approaches the value AJ, where A, the Euler's number, that is equivalent to 2.71828. To determine the maturity value of any amount P at an interest rate compounded continuously, denoted by J sub C, also called forced interest, we use the formula uppercase letter F. This is our maturity value equals uppercase letter P, our present value or the initial amount or the principal, times E raised to J sub C times T. While the formula to determine the present value of any amount F at a force of interest J sub C, we use this formula. P or uppercase letter P equals uppercase letter F times E raised to negative J sub C times T. Okay, let's have the derivation of present value of any amount at a forced interest. So given the formula, this is the maturity value or final value formula. We have to solve for P. Now, divide both sides by E raised to J sub C times T. So this result. So at the right side, only P remains because we cancelled already E raised to J sub C times T. Then interchanging the right is the terms at the right is at the left, placed at the left, and the term at the left is placed at the right. That is because we follow the orientation of our eyes that in mathematical equations, whenever there is a known, it is normally or most commonly written at the left side of the equation. So we have this formula, uppercase letter P, the present value equals the maturity value times E raised to negative J sub C times T. Okay, let's have an illustration. An amount of 234,000 is deposited in a bank paying an annual interest rate of 6.15% compounded continuously. Find the balance after 3 years. So let's have the solution. Principal, which is 234,000. Then our J sub C is equal to 6.5% or 0.0165. And we have a time that is for 3 years. So using this formula, uppercase letter F equals uppercase letter P times E raised to J sub C times T. So we only substitute uppercase letter P by 234,000. then E by 2.71828, then the J sub C, which is 6.15% or 0.0615, then T by 3. Okay, so do the calculation. All you have to do is get a calculator, press the number 2.71828, then you press also the button or the K, which is x raised to y or y raised to x in your scientific calculator. Then the product of 0.0615 and 3, you will get, and multiply the result by 234,000, you have 281,412.34. So this is the maturity value of the deposit of the initial amount, which is 234,000. Another illustration, find the present value of 90,000 pesos, which is due in 6 years from now at 9 and one-third percent compounded continuously. So our future value is 90,000. We have J sub C, which is 9 and one-third percent or 0.09333. Then the time is 6 years. So using the formula, this one, for the present value, so we have to replace our uppercase letter F by 90,000, then E by 2.71828, then our J sub C by 0.09333, then multiply this by 6, then use the calculator, scientific calculator, you do the calculation, you get 51,409.86. So this is the present value or the initial amount to be invested for someone to gain or to have this amount, 90,000 pesos, in 6 years time. Now, compounded continuously. A rate compounded continuously also has equivalent relations with that of effective and nominal rates as shown in the following formula. So W here, this is our effective rate, equals E raised to J sub C minus 1. Now, solving for J sub C, we have to add both sides of the equation by 1. So we get this. W plus 1 equals A E raised to J sub C minus 1 plus 1. So what we're doing here is we are applying addition property of equality. We added both sides of the equation by the same amount, so the equation still holds. So what we will have from this, we have W plus 1 equals E raised to J sub C. And then interchanging, the term at the right is placed at the left. Then the terms at the left are placed at the right of the equation, and that holds because of reflexive property. The idea there is that we just interchange both sides of the equation because we are used to have the unknown at the left side of the equation. So we have A raised to J sub C equals W plus 1. But take note that our goal is to get J sub C. So we have to take the logarithm in both sides of the equation. So this one, we take the logarithm in both sides of the equation. So the logarithm of A raised to J sub C equals the logarithm of the quantity W plus 1. And in here, we got J sub C times the logarithm of E divided by the logarithm of E. Uh, we have this one because the logarithm of A raised to a power J sub C, that is equivalent from the logarithms, law of logarithms. the logarithm of a power, that is just simply equal to the power times the logarithm of the number, or the logarithm of the base of the exponential number. Then in here, we divided both sides by the logarithm of e, because our goal at the left side, or our goal, is to solve for j sub e. So we can cancel this one at the left. So what remains is j sub c equals the logarithm of the quantity w plus 1 all over the logarithm e. Now, illustration. Find the effective rate equivalent to 8 and 1/4% converted continuously. So our J sub C is equal to 0.0825, because this 1/4 can be written as 0.25. Okay, so using the formula for the effective rate, W equals A raised to J sub C minus 1. So substitute, we substitute E by 2.71828, then J sub C by 0.0825 minus 1. So you get 8.60%. Another illustration, what interest rate compounded continuously gives an amount equivalent to 9.95% effective rate. So we are looking for the nominal rate here. Find J sub C. Okay, so J sub C, we have the logarithm of W plus 1 all over the logarithm of E. So we have to replace W by 0.0995, because that is the equivalent of 9.95% plus 1 here. Then the logarithm of 2.71828. So you get the logarithm of 1.0995 divided by the logarithm of 2.71828. So for the numerator here, the logarithm of 1.0995 is equivalent to 0.0411952. And for the logarithm of 2.71828, that is 0.434295. So dividing these two, we have 0.0949. And changing this decimal number into percent, you get 9.49%. Thank you very much for watching.